All right, today we're going to look at just real quickly what do you do when you have what's called radicals as your measurements. So oftentimes mathematicians like to use the radical form of a number, which is just kind of as exact as you can write a value. So here I have a right triangle, and it has a radical length of the square root of 145. So they just haven't found it. They just want you to find it. So we're going to go with a squared plus b squared equals c squared. Pythagorean theorem, it's a right triangle. I know c is 13. I know a or b, whichever one you want, is the square root of 145. And I know that the other leg is x. I could leave it b, I could leave it x. I'll just put x squared in. Doesn't matter. Oh, and I forgot that this is squared. I'm going to put that in parentheses. So a is the square root of 145, but I need to square that. 13 squared is 169. X squared is x squared. And then the square root of 145 squared, I could do that, find the square root and then square it, or I could have realized our connection between our inverse operations that the square root and the square will undo each other, with leaving you just with the radicand 145. So that's kind of a unique relationship with these radicals and our square, right? We can kind of, when we plug them in, they cancel each other out. All right, so I'm going to subtract 145 from both sides. Leaves me with x squared equals 24. And I'm going to take the square root. Again, canceling out the square. So x equals plus or minus the square root of 24, which is 4.898979486. So we're just around 4.9. Here I got two radical form lengths. So a squared plus b squared equals c squared. Looking for a hypotenuse. So I can just leave it c squared. A squared is the square root of 7 squared. B is going to be the square root of 11 squared. My square roots and my square will cancel. So I have 7 plus 11 equals c squared. Add them together, I get 18 equals c squared, and I square root 18. .24. So c equals 4.24. And that is using the Pythagorean theorem with radical form lengths. Hope this helps with radical form.